All right, let's do this. For stoichiometry, that's the overall process of converting from masses to moles, moles to moles, moles to masses, going from any mass to any amount of moles, and so on and so forth, using balanced equations. We're using this term stoichiometry to kind of roll it all into one. Where we can theoretically start is the mass in grams of any substance. For the most part, this can be a reactant or a product. Okay. The next thing we would do is move to the moles of a starting compound. Again, if we're moving from mass to moles, we're staying within the same compound. Anytime we go from mass to moles, we're going to divide by the molar mass. All right, our theoretical next step is to use mole ratios from the first section to go from moles of one thing to moles of the goal substance. This will be a different reactant or product than you started with. To do this, we have to multiply by the correct mole ratio that converts 1 mole of something to moles of something else. The last, but certainly not least, thing we can do on this roadmap of stoichiometry is convert moles back to grams. Of the goal substance. In order to convert from moles to grams, we're going to multiply by the molar mass. Of the goal substance. The molar mass of the starting substance is the one over here. So 2 different molar masses. So the question of today, for your daily Q, was what do you need to do stoichiometry to convert from grams to grams? And the answer to that, the molar mass of your starting substance Sorry, was this yesterday? What? Was that yesterday? Okay. All right. Molar mass of the starting substance. What else do you need? You're going to need mole ratios. How do we get mole ratios again? We need a balanced equation so that we can get mole ratios for the 2 substances, and only the 2 substances we are comparing. So the last thing you need, the molar mass of the goal substance. Could you argue and say that you need a periodic table? Of course you do. Are you going to be given molar masses? No. Probably not. You're going to be asked to calculate them. But here is our overall set of possible steps. And you'll see I've got letters and numbers. Okay? So when we look at a problem, what we're going to look at is where do we start on the map and where do we want to end. And we're going to do this in a very stepwise manner for a reason. We're going to start by identifying what we're given. We're going to try to identify where we're trying to get to. We're going to locate that on our map, and we're going to decide what steps we actually need to do to get from one thing to another. Okay? So let's do our first type of stoichiometry. I'm going to try to leave this roadmap, but I do reserve the right to erase it, so make sure you have it written down. To abbreviate it, I'll put it over here. All right, let's do an equation. These are always going to be word problems. Make peace with it now. This one says, in a spacecraft, carbon dioxide. What's the formula for carbon dioxide? Thank you. Exhaled by astronauts can be removed by reaction with lithium hydroxide. What's the formula for lithium hydroxide? Ooh, I like it. 1 to 1, right? Because OH is a -1. The equation is this guy. Can I erase my schematic-y thingy up here and around? Yeah? Okay. Okay, so here's my actual question. With our roadmap, you do not always have to start with a reactant and end with a product. That is not something that anyone will tell you. Okay, we can do stoichiometry of just reactants if we want. We can move from one reactant to another. We can move from one product to another. Okay, we can stick all of our stuff on one side of this equation if we want to. Balancing this equation gets you this. Please remember the first step in any type of problem. Okay? Step 1 will always be get a balanced equation. If that means you need to look up the formula of something because you don't remember that lithium hydroxide is LiOH, do that. Okay? Get a reaction that is balanced like this. Questions? I see a lot of like heads. Is there supposed to be a 2 in front of my H2O? There's supposed to be a 2 over here.
Where are the hydrogens on the right?
No, there's not.
There's not?
No.
Oh, you're right, because one of the O's goes over there. You're right, you're right. So an oxygen adds to a carbon, a CO2 to give you CO3, your 2 Li's, and then 1 O, 2 H's left. Okay, that's balanced. I'm doubting myself for some reason. Okay, So step 1, balanced equation. Do we have that? Okay, I'm going to move it up here. Is the first part of this problem, this whole thing, important? Does it give you any information that you need to do math? Probably not. It just gives you an introduction into what the reaction is going to be, right? So this whole thing, we don't need it. We do need this guy. So I am going to copy that, and then I'm going to start the next step. Okay. So step 1, balance equation. Step 2, do some identifying. So identify knowns, unknowns, and needed info. Needed info being molar masses, mole ratios, things of that nature. Okay? So what's our known information? What's our goal or unknown? Moles of lithium hydroxide. Okay. Let's identify where we're at before we try to look at needed information. So let's look at our roadmap. What letter are you starting on? What were you given? B, right? Where are you trying to go? C or D? C. So all I need is whatever I require in step 2. What does your roadmap say? Mole ratios. So the only other thing I need are mole ratios. I don't need molar masses, correct? Now, should I write every single possible mole ratio for this reaction? No. I only need one of those mole ratios, and I want to write both of the conversion factors for that one mole ratio. The one mole ratio I need relates the two substances I'm working with to each other, which means I need to write something that relates these two substances. So what are my mole ratio? What am I going to write? I'm going to do 1 mole CO2. Don't forget to write the whole thing out of LiOH, or the flip all right. Our next step is to set up to cancel units. Okay, we're going to start with what we know. We always start with what we know. For the setup. Setting up our multiplication here. Which of my 2 mole ratios am I going to use? The left or the right? The one on the right. Why? Puts my CO2 on the bottom. I don't even need a calculator. Multiply across, divide by what's on bottom. Oops. This is what I'm going for. That's what I'm canceling. And I'm left with, yo.
If it was like 2 moles of CO2, would you divide first and then multiply?
I mean, I like to take what I see in the fraction and just like move it over. So if this was a 2, that would be a 2 on my reaction. You could also just see that that's a 1, but I mean, you can do your algebra however you like, just get the right answer. So there's my warning to you. Do your algebra however you like, but get the right answer. Get the wrong answer, I can't help you. Okay? All right, there's my answer. Ooh, sig fix. Are we good? The first number had how many? 1. Does our last number have 1?
Yeah.
Oh, we're good. All right. Well, let's do another one. Can I erase? Stoichiometry. It's so good for you. It's good for the soul. Oh, you won't hate it by the end, I promise. All right, let's do another one. So that was our simplest situation. Arguably the simplest version of stoichiometry we can do is going from moles to moles, and that's it. Okay? Our next situation is going to involve moving from moles to grams. So this is going to be our type 2. And it references photosynthesis and the reaction for photosynthesis. Oh, yeah. Plus. Thank you. The whole idea is that it produces oxygen for us to breathe. Okay. You got to balance it, don't you? We're here. Step 1, balance. Haven't even given you the problem yet. You balance. I'm going to write the problem. Are we good with the bottom of this one? This last one? Okay. Give this one a break. Who's got it balanced? Didn't you have to memorize this for biology? Yeah. You never balanced it? Did they just make you, didn't she just make you memorize the balanced one?
No.
Wow. Who wants to tell us what the answers are to our balanced equation? Go ahead, Krista.
6, 6, under 1, 6.
Thank you. Nice job. Okay, so we're going to take the same approach we did last time. Start by looking at what we know, what we don't know, and what we need. All right, I like to write goal instead of unknown. I don't know. Same idea. All right, so what's our goal? Grams of C6H12O6. What are we given? Before we look for needed info, let's check our roadmap. After you identify your knowns and your unknowns. So we're starting with moles, which puts us where on our roadmap? A, B, C, or D? B. We're ending with grams, which puts us where on our roadmap? D. Looks like there's at least 2 steps we have to do for this problem. That first step involves what? Mole ratio. That second step involves what? Say again? Molar mass? Of what? The known or the unknown? The goal. So here's what we have. What do we need then to do our 2 steps? We just said mole ratio. Take it a step further, mole ratio of what 2 things? H2O to the C6H12O6 glucose molecule. What else do I need? Molar mass of the goal substance, which is C6H12O6. Do this in your notes. See what you get. Stoichiometry dance. Molar mass dance. Waiting. What is going on over there? You got it written down? What's the mole ratios I need? What are the 2? And the opposite. What's the molar mass of C6H12O6? I got 180.18, but they're all the same. Remember, they're just supposed to be very close. Okay, let's set it up. Looking for a place that I can go and try. Always start with your given. So our 3 moles of water in this particular step, we're taking from our roadmap to do step 2, which means a mole ratio, right? Which mole ratio should we use, the top or the bottom? The one on the bottom. So our 1 mole of the glucose goes on top. Okay? I'm just going to do this 1 step at a time, but in theory you could keep going. What do we get if we do this? In our calculators. You said what? Okay. Our next step is going to be to continue so that we can do number 3. Use the ending result of the first step to move on to the second step. In the next one we do, I will do them all in one, just for fun. You don't have to do it that way. If you're tracking this 1 step at a time, and that's how you like to do your math, do it. The molar mass is 180.1566. On your roadmap, I specifically wrote either divide by the molar mass or multiply by the molar mass. Which one should we be doing here? We should be multiplying. And what we'll see is, remember, that 1 mole is the bottom of any molar mass, right? If we're dividing by the molar mass, we're putting 1 mole on the top of the fraction. If we're multiplying, we're putting the 1 mole on the bottom. And the mole cancels. Don't forget that this is of C6H12O6. So in your calculator, what do you get? 90. How many sig figs does your original number have? 3. How many does this one have? How many does it have now? What's the unit? Thank you. Grams of glucose is the entire answer. Okay? How you feel about stoichiometry so far? Thumbs up, thumbs side, thumbs down. We don't like it or we don't understand it? That's what I'm looking for, is understanding here. That's fair. You don't have to like it. You just have to do it. All right, let's do another one. Let's do the bad boy. Start with grams. Go to grams. You got this. Leave my roadmap. Are we good? We good? Okay. Tin 2-fluoride is used in some toothpastes. It is made by the reaction of tin, metal, with hydrogen fluoride according to the following equation. The question asks, how many grams of tin 2-fluoride are produced from the reaction of 30 grams, 30.00 grams of HMAT. So now that we have our information, let's start with our balancing. All right, what's the balance equation looking like?
1, 2, 1, 1.
All right, 1, 2, 1, 1. Do we agree? I agree. All right, let's start with what we know. What's our known information?
3 grams of HF.
Nice. And the goal?
Grams of
Tin fluoride, right? Tin 2-fluoride. Okay, look at your roadmap. What do you need? Where do you start? We're starting at A, right? Where are we ending? All the way at the end. So we need to do all 3 steps, which means we need the molar mass of the known. What do we need for step 2? A mole ratio. And then what else? Okay. So we need the molar mass of SNF2. We need the molar mass of HF. And we need the mole ratio that compares HF to SNF2. Get it written down. Do the math. You've got a periodic table to the left. When you come to class for the next few days, you need to be grabbing a periodic table to work with at your desk. Did you already get it? What's the molar mass of the first one? SNF2. I can check your numbers. Yep, and then what'd you get for HF?
20.00635.
Let me keep my stuff separate. All right, what are your mole ratios? Ooh, not rations.
1 mole SNF2.
Okay.
Over 2 moles HF.
Or the opposite. Those of you hating on stoichiometry, stop dropping things like the name of the substance or the word moles. If you do that, you will get lost. I promise. But that's on you. Don't take shortcuts. They don't exist here. Not for you and definitely not yet. All right? So we have everything we need. Where are we going to start? With step 1, where we convert our grams to moles by dividing by the molar mass. And again, I'm going to do this in all 3 steps in one, and I will label them. We start with 30 grams of HF. We divide by the molar mass. Please remember what the actual molar mass represents. Grams per mole, 1 mole to be exact. This is part 1, or step 1 on your roadmap. Step 2 is to convert moles of HF to moles of SNF2. So which of my mole ratios should I use? The one on the left or the one on the right? The one that I wrote on the right. The one that cancels out HF by placing it on the bottom of the fraction. Step 3 is to multiply by the molar mass of your goal substance, which we found to be 156.7078 grams. Again, do not drop units. Not now, not ever. From here, you can cross off anything that is on both top and bottom of your fractions. That should leave you with your desired units, in this case, grams of SNF2. When we plug this into our calculator, you multiply everything on top, divide by everything on bottom. Since all we are doing is multiplying and dividing, what determines our sig figs in this problem? The starting number, which has how many? 4. Your final answer should also then have 4 sig figs. What did you get? Grams of SNF2. If you do not write all of that, your answer is wrong. And I'm very mean about it. Whoa. You all right? Okay. Your exit ticket. Is this one. I want to see the whole thing. Please don't forget to balance the equation. You can go over and take a picture. You can't see. I have to show my video anyway. Hi, Sean. Sean, we miss you. Some of us more than others, I think, but I miss you.
Only 5 years.
He'll be back next week, right? There you go. This is your exit ticket problem. And then you're done.